Okay, these next three problems on page 4, the first three problems of page 4, ask how many solutions are there to the system. Now there are three different responses to this. Now remember, a system is really just two lines. So if we would think about this, in this situation, if you had a system, you could have one option. Let's say this is a coordinate plane, and you drew a line on here. You could have an option where they cross like this. And when they cross, the solution is where they cross, and they cross at one point, so it could have possibly one solution. Another option to a system is it possibly having no solutions. And that's a situation when you have two parallel lines that never cross. Notice these don't cross, therefore there is no solution. The third situation is a situation where you have two lines and they are right on top of each other. So here's one line and then here's another line right on top of it. This has infinite solutions. So there are infinite points where these two lines cross, thus an infinite solution. So we need to figure out what the situation is. Are there no solutions, two solutions, or one solution? Well, these lines have the same slope but different y-intercepts. These lines are the same lines, so we're going to see if we can find something that has the same lines. And these are just different lines altogether. Different slope, different y-intercept, possibly the same y-intercept. You never know. Okay, so let's get off. Let's take a look at this one and figure out how many solutions it might have. Well, let's take a look. One way to do this is try to solve it. And if you can't find a meaningful solution or something that just doesn't make sense, that can give us a clue to if there are no solutions, infinite solutions, or one solution. So let's try solving this using, how about we use elimination? Okay, so elimination, we want to eliminate one of these variables. Let's focus on the x. We could do the y, but let's do the x. The x, we need to get these to be the same, so I'm going to multiply this whole top by 3. So if I distribute that there, and there, and rewrite it, I got 3x, 3 times 3y is plus 9y, and 3 times 3 is 9. Okay, so I got these two equations right here. And now I want to get rid of one of them, so I'm going to subtract. So 3x minus 3x is 0x. Negative 1 minus 9 is negative 10y. And negative 11 minus 9 is negative 20. This gives me negative 10y equals negative 20. So I have y divided by negative 10 equals 2. Okay. Solve for that. Now can I take this and put it in there? Well, I could take it and put it in there and probably solve. We would put in this one, 3x minus 2 is equal to negative 11. If I took this 2 and put it in there, there's no reason why I can't solve for this x. So does this have a solution? I bet it does. It's got one solution right here. This has one solution. Okay. So let's move on to this one. Let's see what's going on with this one. Well, gosh, right away you look at this and you notice this is the same as that and this is the same as that. And if we were to bring this over here and find the slope of this line and this line, they'd be the same, but the only thing that's different is this right here and right here. What this stuff does right here is going to determine the intercepts. And you can tell by looking at this that the intercepts are going to be different. So we're talking about a situation like this, where we have two parallel lines, but with different y-intercepts. And because they're different y-intercepts, they'll never cross. And if they never cross, we will have no solutions. Okay. And lastly, how many solutions to this system right here? Well, it's not as obvious what's going on here. But let's see if we can maybe do the elimination method here. What I do want to point out is 4 is twice 2 and 16 is twice 8. So it looks like we might have the same slope. Let's try to eliminate, how about this y? So we want to multiply this whole top by 4 to make this 2 and 8. So we'll multiply it by 4. We'll rewrite that down here, 4 times this, that, and that. So I get 16x plus 8y is equal to negative 16. Okay, what do you notice about these two equations right here and here? Well, they're the same. They're identical equations. 16x, 16x, 8y, 8y, negative 16, negative 16. If you have the same equations, what you really have is one line right on top of the other line. So in this situation, there are infinite solutions. Okay. Moving on to for graphing the inequalities. Okay, so now before we were graphing equations, and there was no shading. Now when we're graphing inequalities, we got a couple other things we have to deal with. First off, we might have a dotted line, which means the any solution on that line is not part of the solution. And the second thing is we have to shade. So we're going to go through the graphing this inequality. The first thing I like to do is get it in slope-intercept form. So I'm going to start by subtracting 4x. So I got 2y is less than 4 minus 4x. And I'll divide by 2. Everything by 2 to get that y by itself. So I got y is less than 4 divided by 2 is 2 minus 2x. Okay, so we got this. Now let's put our line together. Now we got to figure out, is it solid or dotted? Well, when we look at this, if the alligator is like this or this, we got a dotted line. If it's less than or equal to or greater than or equal to, we got a solid line. So let's do this like it looks like that. This is solid. Is it solid or dotted? It's solid or dotted. It is a dotted line, one of these. So let's start by finding the y-intercept. Well, the y-intercept is given right there. That's that 2. It's not connected to the x, so we'll put a dot at the 2. And now we need to find the slope. The slope is right here, so it's got a slope of 2, which means you go up 2 and over 1. So we'll go up 1, 2, over 1. Up 1. Oh, can't go that way, so we'll go down this way. 1, 2 over 1. 2 over 1. And you make a dotted line. The best you can make it. Remember, any solution on this line is not a solution, or any point on that line is not a solution. I should say that. Okay, next step is the shading part. We either shade above it or below it. Now, the key thing here is, if you practice this enough, you know that since the alligator is not eating the y in this form, you would shade below it. But what if you didn't know that? What if you forgot that? Well, the key thing to do is pick a point. And you got to pick a point that's not on the line, and if 0, 0 is not on the line, that should be the point you pick. It's the easiest one. And what we're going to do is we're going to take this point and we're going to put it into our equation there. And once we simplify everything, if the statement is true, if whatever is less than whatever is a true statement, then we shade on the side where the point was picked. If it's false, we shade on the other side where the point was picked. So let's just see what happens. We're going to take, we got 0, 0, so y is 0 is less than 2 minus 2 times 0. So 0 is less than, well, this is just 0, so we got 2. Is this true? I bet that's true. 0 is less than 2. Since 0 is less than 2 is true, we know that we shade on this side. There we go. Nice and shaded. Okay. So that's number 40. Moving on to number 41. So here it says graph the inequality. This is just like the last problem, except guess what? Get that negative there. I bet that does something. So first step, get y by itself. So let's subtract the 5x, subtract 5x. So what we have, and I'm going to move this off to the side here, negative 3y is less than or equal to 6 minus 5x. Okay. Next, we got to divide by this negative 3. But remember from earlier, when you divide by negative and dealing with inequalities, you have to change the sign. So we'll do that here. So we have y, because that cancels off. We change the sign because we divide by negative. 6 divided by negative 3 is negative 2. Negative 5 divided by negative 3. Well, we're talking positive there, but sadly it's 5/3 x. It's kind of a messy little fraction there. Okay. So now we need to graph this one. We'll start at negative 2. That's our starting point right there. And we have a slope of 5/3. That's our rise over run. This is our m. That's our b. So we'll go up 5. And because it's positive, we know it's going like this. It's a positive slope. So we'll go up 5. Oh my gosh. Did you see my mistake that I made? Go come back to this one. Check this out. What was my slope? Negative 2. So why did I go up 2 and over 1? I should have gone down 2 over 1. Oh gosh, I am sorry. So this goes down like that. Even teachers make mistakes. Okay, and it looks like this. And then shaded, still shaded below, because that still came out to be false. Okay, or true. So I'm sorry. Okay. Oh, and this is dotted. Again, another mistake made by Mr. Benson. Okay, so moving on to this one. Back here we got a slope of positive 5/3, so we go up 5 and over 3. 1, 2, 3, 4, 5 over 3. 1, 2, 3. There's it. Is it solid line or dotted line? Well, it's equal to, so it's a solid line. Just connect our lines like that. Nice solid. Okay. Now we got to figure out which way do we shade it. Well, the alligator's eating the y, and it's in the y equals mx plus b form, so we know we shade above. But again, if you forgot, you can choose the point 0, 0, as long as it's not on the line. Plug that in here. So we have 0 is greater than or equal to negative 2 plus 5/3 of 0. So we have 0 is greater than or equal to, well, this is 0, so negative 2. Is 0 greater than or equal to negative 2? It's just got to be one or the other. Yes, it is. Therefore, we shade on the side with the dot. If that was false, we would shade on the other side. So, shade right there. Hopefully I got my slope right on this one. Sorry about the number 40. Okay, right there. Remember, it's going down, dotted line going down like that. Okay, moving up to 42. Given a feasible region with vertices of 3, 4, 5, negative 2, and 6, 2, and an objective function of p equals 2x plus 3y, find the maximum and minimum value. Okay, so remember, so we're dealing with linear regression, or sorry, not linear regression, linear programming problems here. And to maximize or minimize a function, a linear programming problem, you need to test the corners of the feasible region. Now, they gave you the corners, so we don't need the graph. They just gave us the corners. Now we just need to test. One of these corners is going to max out this function. One of these corners is going to minimize that function. So we just got to plug them in. So let's start with first the 3, 4. Let's plug that into this right here. So what do we got? We got 2 times 3 plus 3 times 4. 2 times 3 is 6. 3 times 4, so we got 6 plus 12, this is equal to 18. So 3, 4 gives us an 18. We don't know if that's a max or min yet. We've got to test all the points first. We also have 5, negative 2. Okay, so let's put that in there. We have 2, 5 plus 3, negative 2. This gives us 2 times 5 is 10. 3 times negative 2 is minus 6. So this gives us 4. Okay, so far our max is 18, our min is 4. Okay, let's try our last point of 6, 2. So we'll plug that in, 2, 6 plus 3 times 2. So 2 times 6 is 12, 3 times 2 is 6. Did I do that right? 2 times 6 is 12, 3 times 2 is 6, so this is 18. Okay, so it looks like we have a tie. Find the maximum and minimum. It looks like 3, 4, and 6, 2 will max out this objective. This is our max. And this one right here is our min. That will minimize the objective function right there. Okay, moving on. Number 43. It says a factory employs skilled laborers at $25 per hour and unskilled laborers at $12 per hour. The hourly cost of the factory's 24 workers is $405. How many of each type of labor works at the factory? Okay, this is a system. We just got to bring things together. So let's read that one more time. A factory employs skilled laborers at $25 per hour and unskilled at $12. So it looks like we have two things going on here. We have X, let's make that skilled laborers. If Y is unskilled laborers. Okay. So if actually employs skilled laborers at $25, that's how much these guys cost. I'll just put that there, 25 bucks an hour. And these unskilled laborers, they're cheap, $12, but they don't do nearly as good of a job. Okay. The hourly cost of a factory's 24 workers is $405. So we know that they have 24 workers, and every hour they spend that much money. Okay. So how many of each type of labor works at the factory? So let's set up our inequalities. First is number of workers. We got an equation for the number of workers. Okay. So in this situation, the number of workers would be 24. That's how many workers we have, and that's equal to our number of skilled laborers, X, plus our number of unskilled laborers, Y. Okay. The next thing is money, amount of money. Now, they spend $405 per hour. For each skilled labor, they spend $25. So 25 times X would tell you how much you pay for them. And for each unskilled labor, they pay $12. So 12 times Y is what they pay them. Okay, so we got these two equations right now that we need to solve. We need to figure out. Yes, this is just like here, solving these systems over here. So let's give this a shot. We can use substitution, we can use elimination. My favorite is elimination. Let's eliminate this Y. How about? Let's eliminate the Y's right here. So we need these Y's to be the same, which means I'm going to multiply this top by 12. That is going to go there, there, and there. So what's 24 times 12? Grab our calculator quick. 288. So I got 288. Okay, remember that's this equation. I'm bringing it right down here. Equals 12x plus 12y. Okay. Now since I'm trying to eliminate these, what I'm going to do is I'm going to do subtraction here. I'm going to subtract the two equations. So we got 405 minus 288. So I got 117 for this. 25 minus 12, 25x minus 12x is 13x. And 12y minus 12y is 0y. Pretty much that cancels that out. So that's gone. Let's divide by this 13. Hopefully 117 is divisible by 13. And thankfully it is. Okay, so we get 9 is equal to x. So we know that there are x skilled laborers there. Or 9 skilled laborers there. Well, now we got to figure out how many of the unskilled. So let's just take this equation. This is a nice easy one. So we know there's 24 skilled laborers. Of them, 9 are skilled. How many are not skilled? Well, let's subtract 9 from both sides. We got 15 is equal to y. So there are 15 is equal to y. So we got 9 skilled and 15 unskilled laborers. Okay, moving on to chapter 6. I think we go back to chapter 5 later. Chapter 6 is all about exponential growth. So, and decay. Growth and decay. So here we need to predict the population after 4 hours of 1,000 bacteria that doubles every hour. Okay, so our durations, we have 4 durations, and it doubles every 1 hour. So we're going to use a couple of things. Well, first we know it's doubling. That means our multiplier is 2. Our start, how many bacteria do we have? Well, that's 1,000. And how many durations do we have? That equals 4 in this situation. Now, what if it was it doubled every half an hour and there's 4 hours? Well, then our duration would be 4, or would be 8, right? But because it doubles every half an hour. But this situation, it doubles every hour and we have 4 hours. So our equation for this, we have 1,000 times 2, the multiple, to the 4th power. We just got to figure out what that is. Take that, put it in the calculator. So really what you want to do is 2 to the 4th power, figure out what that is, and then multiply that by 1,000. And you get 16,000 as your answer. There will be 16,000 bacteria in the system after 4 hours. Okay, moving on to number 45. The present population of the country is 2,321,255. The population is growing at a rate of 1% per year. Not too fast. Write an expression to represent the situation. Okay, so first we want to find the start. Well, our start is 2,321,255. Then we need to figure out our multiplier. Well, in this situation we have 1%. That's how much it's increasing by. So we have to change that 1% to a decimal. Change that to a decimal, we're going to do 0.01. Remember, divide that by 100 or move the decimal spot over 2 times. So we move that over. But now, because we're increasing or it is growing, we have to add that to 1. So it's 1 plus 0.01, which is really equal to 1.01. So there's your multiplier right there. And now the duration. The present country is population. Well, we don't know the duration in this situation. They're going to ask us over here. That's the unknown, the time. So our expression for this would be 2,321,255 times 1.01 to the unknown duration, which is x. And there's your expression. So the next problem says, okay, now you got your expression, predict the population after 8 years. Well, that's your duration right there. They just gave it to you now, finally. So really, we just have to take this and put it into there. So let's just rewrite this as 2,321,255 times 1.01 to the 8th power. I'll just plug that in the calculator and see what it gives us. So 2,321,255 times 1.01 to the 8th power. And we get 2 million. This is equal to 2,513,586. And there's a part of a person right here. They give you 0.542, a half a person. But that really is not meaningful. We don't care about that half a person until they're a full person. So in the course of 8 years, the population will probably increase about 200,000. That's the difference between this and this. Okay, moving on to number 46. We're almost done with page 4. This one says identify each function as linear, quadratic, or exponential. Now remember, Linear is really just an x term. It'll be like, y equals mx plus b or something. There's no square on the x or anything like that. Quadratic will have something like f of x or y, and then it will have an x squared term in there. Nothing bigger than that, just an x squared. So we've got x squared plus 2x plus 5. That's a quadratic. And then we got exponential. This situation is when you have y is equal to a number, say 2 to the x power. So you know the variable is in the exponent. That's what makes it exponential. Okay, so let's take a look at this. We have a function here. We have a variable in the exponent. Therefore, this is exponential. Okay. Here we got f of x is equal to x over 2 plus 3 halves. This has no square, no exponent in the, or x or variable in the exponent. So this is linear. It's kind of disguised because this x is on top. This is really, if you were to rewrite this, this is f of x is equal to 1/2 x plus 9. So there's your linear equation. Here, looking at this, we got a square or 2 in the exponent, so this is quadratic. Here we have f of x is equal to, oh, look at, our variable is in the exponent, so exponential. Now this one's tough to tell, right? You don't have any x squares or anything, but if you were to use the box method on this and figure out what this turns out to be, we will find something interesting here. Let's do that quick. Okay, so we're going to do the x plus 2 on top, and we have x minus 3. And right off the bat, check this out, we get x squared. And then we've got negative 3x from that, and here we get 2x, and here we get negative 6. But this x squared tells us what? That this is quadratic. Sorry, you couldn't see the box, could you? Here we go. Box method. If they're x2, x minus 3, we get this x squared. Thus, this is quadratic. And that is the end of page 4.